So let's take a look at the counted loop in MATLAB, which is the for loop. Here's an example. We have the reserved word for, we have our loop or iterator variable I, gets the value of the range 1 to 3, so that's specified as a vector. And then we have the action, whatever the action is, naturally bracketed by the reserved words for and end. So I is going to go through the values 1 and then 2 and then 3, and for each value of the variable I, we're going to execute the action. I and j are very commonly used as loop variables in many languages. Notice that in MATLAB, both I and j are built-in constants for the square root of -1. So it's a little bit risky to use I and j in MATLAB as loop variables. But if you're not planning to use the square root of -1, it's not a big deal. So the range is specified by a vector, and that can be any vector as we'll see, but usually it's going to be the colon operator. So you're specifying in this case that we want the action to be repeated 3 times by saying 1:3. So here's an example of a for loop in MATLAB in which we're actually using the iterator variable in the action of the loop. So let's keep track of the value of the loop variable I. So I is going to start at 1, and when I has a value 1, we're printing I is and the value of the variable I, which is 1. So the output, we're printing I is 1. Then I gets the next value in the range, or in the vector, 2. Then we print I is and the value of I, which is 2. And then I gets the next value, 3. And we print I is 3, and that's the last value in the vector. So I iterated through the values 1, 2, 3. For each one we printed the value of I, and then when we get out of the loop, we're going to print and now I is, and I is still 3. So we print and now I is 3. So again, here we're using the iterator variable where I is iterating through the values 1, 2, and 3, and when we get out of the loop it still has the last value of 3. Now any vector can be used for the range. It's common to use the colon operator, but not necessarily. So this one says I gets a value of, and then we have this vector that has 3 values in it, 4, 11, -2. The same action as before, we're going to print I is and the value of I. So when I has the first value 4, we're printing I is 4. When I has the second value in the vector 11, we're printing I is 11. When I has the third value in the vector, -2, we're printing I is -2. And then when we get out of the loop, after we've gone through the 3 values in the vector, I is still going to be -2. So I is going to retain the last value in the vector. Here's an example in which we're not using the iterator variable in the action of the loop. So the vector in this case is just specifying how many times we're going to repeat the action. So in this case, back to the normal using the colon operator, I gets the value of 1:3. So when I has a value 1, we display hello. When I has a value 2, we display hello. When I has a value 3, we display hello. And that's it. So in this case, any vector that has 3 elements would accomplish the same task, but it's more common to use the colon operator, and it's more clear using the colon operator that we're iterating 1, 2, 3 times. Now, a common application of a for loop in many languages is to use a running sum, and that's certainly something that you can do in MATLAB as well. So we might have a running sum variable that we initialize to 0. I is going to iterate through all of the values from 1 through 5, and for each we're going to take what we currently have in the running sum and add that to the value of I, and then store the result back in runsum. So runsum gets the value of runsum plus I. So when I has a value 1, we have 0 plus 1 or 1, and then we're adding 2 to get 3, and then 3 to get 6, and then 4 to get 10, and then finally 5 to get 15. So we're adding 1 plus 2 plus 3 plus 4 plus 5 is 15, and then we print that result at the end. So the output is going to be the sum is 15. So yeah, that's definitely something that you can do in MATLAB, but why in the world would you want to? There's a built-in function in MATLAB that'll do that for you. Sum 1:5, sum, and pass to it a vector. It's going to add all of the elements in the vector to give you the result, in this case 15. So this is what is called vectorized code. With many languages, it's necessary to loop through the elements of an array, meaning either a vector or a matrix, in order to perform the same operation on each element. With MATLAB, that's usually not necessary. You can use built-in operators and you can use built-in functions instead. So this is called vectorized code in MATLAB. So there are lots of useful built-in functions that you can use to do very common operations. So as we've seen, the sum function is going to sum all of the elements in the vector. Sum 1 colon 5 is 15. The prod function will instead multiply all of the elements in the vector. So 1 times 2 times 3 times 4 times 5 is 120. Now, if you're starting at 1, that's the same thing as a factorial. So factorial of 5, which is written as 5 and exclamation point, factorial of 5, and of course there's a built-in function in MATLAB to do that for us. Factorial of 5 is 5 times 4 times 3 times 2 times 1, or think of it the other way around, 1 times 2 times 3 times 4 times 5 is 120. Some other useful functions in MATLAB, min and max. So here's a vector that has 4 elements in it. The minimum value in that vector is -4. The maximum value in the vector is 33. So with a lot of languages, you'd have to loop through the vector yourself and figure out what the minimum value is, figure out what the maximum value is. But in MATLAB, we have built-in functions to do things like this. There are also cumulative functions that will give you the cumulative or the running sum or product or minimum or maximum. So for example, just to have this to look at, vector 1, 2, 3, 4, 5. Now if we said cum sum of 1, 2, 3, 4, 5, it's going to start with the first value, 1, and then it's going to add the second value, so 1 plus 2 is 3, and then 1 plus 2 plus 3 is 6, and then add 4 to that, we get 10, and add 5 to that, we get 15. So it's the cumulative or the running sum. We start with 1, and then add 2 to get 3, and then add 3 to get 6, add 4 to get 10, add 5 to get 15. Cumulative product will accumulate the product as it goes through and multiplies all of the values. So again, starting with the first value, 1, and then 1 times 2 is 2, 2 times 3 is 6, 6 times 4 is 24, 24 times 5 is 120. So with these cumulative functions, for example, cum sum and cum prod, notice that the resulting vector is going to be the same dimensions as the original vector. So for doing cumulative sum or product on 1 colon 5, a vector that has 5 elements in it, the result is also going to have 5 elements. So, as we've seen, we can use vectorized code, but if you wanted to do something like prompt the user for a value, that's when you would need to use a loop in MATLAB. So for example, if I know I want to get 3 numbers from the user, then I would use a for loop to repeat 3 times. So for I gets the value 1 colon 3. In this case, the action is to prompt the user for an integer, read into a variable num, and then echo print what the user entered. So the output might look like this. It's prompting me to enter an integer. I type in 33. It echo prints you entered 33. Then it prompts again for an integer. I type in 11. It says you entered 11. Prompts again a third time for an integer. I type in 5. It echo prints you entered a 5. So 3 times we're repeating the process of prompting the user for an integer, reading it in the value, and then echo printing it.